Alright, so yesterday we looked at two-way tables where if we had two lots of categorical data. So today we're looking at if we have what we can do if we have a numerical and a categorical. So we can use one of two things, and we can use parallel box plots, or we can use parallel dot plots. In my opinion, the box plots are more useful than the dot plots. So let's have a look at what we would do. So for the box plots, so since we've got a numerical and then a category, so each box, if you like, would be one category, and it would give you the numerical spread, interquartile range, median, etc. of each of the categories. So for our parallel box plots, we would have our categories and then our boxes and then our numerical data down here. And if we were using dot plots, it would be parallel dot plots, it would again be the same kind of thing. We would have our numerical and our categories. So we have dot plots. Alright, so we have a dot plot for each of our categories. Here we would have a box plot for each of our categories, and then our numerical stuff alongside. So here's an example. So the following example. Shows the salary. Which will be the RV. So generally with these things here, it will be our numerical is usually our RV, and then our categories would be our our EV. So our categories could be age groups or something. So how do these different age groups affect this down here? So in this case the salary for 4 different age groups. The age groups are our explanatory variables, and our RV would be our salary, I should say, would be our response. So the question would be, being in a different age group, does that associated with a higher or a lower salary or whatever? So in this particular one, we have 4 age groups. Let's have a look. So So what I'm going to do is I'm just going to draw different colours for for each of the age groups. There's nothing significant about the different colours other than just to highlight, alright? So the 4 age groups are the 20 to 29 age group. The next age group is the 30 to 39. 40 to 49. And then 50 to 65. Okay, so now I'm going to use 4 different colours, and as I said, all they are doing is showing us difference, so we can't not getting confused. That's all. No more significance than that. So there's the box for the 20 to 29s. Green's the 30 to 39s. Blue for the next one. And then we'll go purple for the last one. Don't worry about getting those numbers precise, just make it look like it looks. Because quite clearly, if you were given a question like that, they would have to print the question out a bit more accurately than that. All right, now I've forgotten some labels, forgotten down here, this is the salary, and it's in thousands of dollars. So 10,000, 20,000, 30,000, etc. per year. And if it's a salary, it's per year. All right, so from that we can look at and see whether you think there's an association between age groups, salary. So what do you think? Yes, there would be. And so you can hone in on any particular thing. So what what things look like they change as people get older in the workforce?
The starting point is higher.
Starting point seems to be higher, yep. What else?
The median.
The median seems to get higher, yep. What else?
There's more outliers the higher.
More outliers the higher, yep. So that then leads to the range or the spread. Seems to be more as they get older, yep. So you could use any of those things to, as I said, you can say whatever you like, but you need to support it with some sort of evidence. Okay, so we would say there is an association.
Is this between the wrist and the height thing that you were doing the other day?
Yesterday.
Was there a correlation between that?
We don't know.
I don't know.
It was just made up.
Oh,
It's made up.
oh, just made up. Oh, okay.
Just
Sorry.
made it up.
Sorry, I just thought that was interesting. Sorry, Mr. Synno.
Well,
What relationship are you talking about today?
we're talking about how old you are and your salary. So your age groups are not in
So
here.
you're loaded and I'm not. Is
Yeah,
that?
so you're not in here. It
No, I'm not in
starts
there.
at 20,
No, yeah,
so
that's
we
right.
haven't got you in there.
Hold on.
And it stops before me. So
To everyone watching at home.
a little bit of a comedic interlude there. All right, so here we would say there is an association between age and salary. All right, so what can we use? So our evidence that we could use, because these numbers aren't great, I'm going to actually work it out. All right, could be could be. All right, so we had the lowest, the minimum salary, if you like. So the minimum increases with age. One of the others said the median increases with age. Someone else said the outliers, the number of outliers increases with age. I said the range. And the IQR as well, by the looks of it a little bit. Right, so we can see those. So if I had better data, we'd actually make some calculations and put some numbers in, but I don't have good data there. All right. Now, dot plots. I already mentioned that they can be used, but it's a bit more difficult because with the dot plot you would have every person's piece of data. And then you have another dot plot with every person's piece of data. So the associations with dot plots are often a little bit more difficult to see than they are here with this. So a parallel dot plot could be used.
They do, but it's just an example where you do those two ones because they generally score the highest.
All right, a couple of other things that we can use is if there's just two things we're comparing, two categories. Whereas here there's this one, there's 4 categories. If you have a situation where there's 2 categories, you can use back-to-back stem plots. But only if there's 2 categories. So back-to-back stem plots. Alright, so if there's 2 categories, so you'd have your thing in your middle, stem, and then you'll have your and so there's your 2 categories are here. So one category, call it category A, and over here we've got category B, for example. Let's write that a bit better. So we've got an option there for a back-to-back where we can compare these 2 things, but you can only have 2. You can't put in a third or more, you can only have just 2 categories. So for our parallel box plots and our back-to-back stem plots, the easiest thing for us to do would be to look at the median. So look at the median, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 halfway, 1, 2, 3, 4, number 5 is there. And this other one, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1, 2, 4, 5, 6. Alright, so if they're the medians, that's probably the easiest thing for us to compare is the 2 medians in category A and category B. And you can see one's 35, the other's 24, so there's a difference there. So there could be some sort of association. Right. Other than that, to find out more things than that's going to be more difficult. And you'll have to do more work. So for these, so for parallel dot plots, and our back-to-back stem plots, the median is often the most convenient thing to use.
To determine the association.
Yeah. All right. Whereas that first example where I had those 4 categories and those box plots, when you look at that, those things that people suggested came very easily. Whereas with these numbers here, it's not quite as visual, is it? It's not quite as clear visually as those box plots were. So it's not until you actually start then work through and find some actual things. So in this case, the median's the easiest for us to get to compare. All right. Anything else that needs clarifying there. All right, that's it. Don't forget to like and subscribe.